Algebra 2, we're at 9.2b now, and we're going to talk about horizontal translations and absolute value, or other grouping symbols. We've got 5 previous videos for this unit so far, for this chapter, and if you become lost or confused, you can click in this description to find out what you missed. Translations can be horizontal. We talked about vertical translations in the last video. If we replace x with x minus h everywhere it occurs in an equation, we'll translate the graph h units, the absolute value of h units, horizontally. When h is greater than 0, our graph translates to the right, and when h is less than 0, our graph translates to the left. And an absolute value equation will make a V-shaped graph that opens upward or downward. So we've got x minus h, that's going to make it translate horizontally. Now we talked about this in the previous video. If we've got the absolute value bars just around the x, then it's going to go downward. We have a minus sign here, don't we? A subtraction sign. When we have an addition sign on the outside of the bars, it's going to go up. But we have to be careful when it's all inside of the absolute value bars, or even parentheses, any grouping symbol. If we have a subtraction sign inside the absolute value bars and then our constant, it's going to go right. And if we have an addition sign inside the absolute value bars, it's going to go left. So we have a graph of y equals the absolute value of x. That's this black one right here, where the tip of the v, the vertex, is at the origin 0, 0. And this black one's also called the parent function, or parent graph. We have a translation of it moved 2 units to the left with the graph y equals the absolute value of x plus 2. So because this is an addition sign, we're going to move to the left 2 units. 1, 2. And now the vertex is at negative 2. The x has been replaced by x plus 2. Or you can look at it as x minus a negative 2. So our h, our constant, is negative 2. If we distributed that negative in, we'd have x plus 2, wouldn't we? This is also called a horizontal shift. So you might hear it called a horizontal translation or a horizontal shift. So if we have y equals the absolute value of x as our parent function, and we have the equation y equals the absolute value of x minus 3, the graph translates down 3 units. We have a minus 3 outside of the absolute value bars. And if we have a plus 6, the graph is going to translate up 6 units. We've got a plus 6. But when they're inside the absolute value bars, our operation sign, this graph translates right 3 units. It's inside the absolute value bars, so it does the opposite of how it looks. And this is a addition sign with a 6, so that's going to translate left 6 units. It's like x minus a negative 6. It's inside the absolute value bars, so we're going to do the opposite of how it looks. Okay? So a number adding or subtracting inside parentheses or other grouping devices of a function will create a horizontal shift. It affects the x-axis. And the numbers in this function do the opposite of what they look like they should do. So if our parent graph is y equals the absolute value of x, we've got it right here in black. And if we've got the absolute value of x plus 3, it's going to shift 3 units to the left. See that? So if addition is inside absolute value, we go to the left, okay? If it's a plus and then the constant, we go to the left. And now we've got our parent function right here, y equals the absolute value of x, and now we've got an x minus 3 in absolute value. So we're going to move to the right 3 units. We're going to go 1, 2, 3. So when there's subtraction inside absolute value bars, we're going to go to the right. So if it's minus the constant, we go to the right. See? And you might see parentheses. If we have a circle and our parent function is x squared plus y squared equals 1, and it has a translation or a shift to the right, we've got x minus 1 squared. So we're going to do the opposite. We're going to go right 1 unit because of that grouping symbol. So our red circle is going to shift to the right. See? So 4 squares makes 1. I tried to make this as big as possible. See, negative 2 is way over here. So this shifted 1 unit because I made it so that the graph had 4 squares equals 1 unit. See that? So now it moved over to here, see? So if our parent function is y to the absolute value of x, in translation, our shift right would be y equals the absolute value of x minus 4. If you looked at it as a function table, we've got right here, if you look, for our x and y values, we've got a -3 and a +3. We've got a -2 and a +2. We've got a -1, +1, and a 0, 0, don't we? Then it goes 1, 1, 2, 2, 3, 3. See? Like that. So we have -3, 3, -2, 2, -1, 1, and it continues down the function table. So because this is an absolute value bars, we're going to do the opposite, and we're going to add 4. So -3 plus 4 makes a 1. -2 plus 4 makes a +2. So our pink graph, V-shaped graph, our new coordinates for x are going to be these because we added 4 to these, see? And then the y doesn't change. The y just shifts over. So these are all the same numbers for y, see that? So we could just add the 4 to our x value and get our new x value for our translation, okay? So I know this can be really confusing, and just try your best. Watch the previous videos if it's really confusing. Our next video is 9.3a, and we're going to talk about vertical stretching and shrinking. And I'll add this to the Algebra 2 playlist. I'll have a link to Algebra 1's Chapter 12, Relations and Functions, and a link to those previous 5 videos for Chapter 9, okay? So I'm going a little slower than most schools go for Algebra 2, and I hope this is helping some of you, and I hope it's kind of an enrichment for those of you who are still in Algebra 1 that might be watching this. I hope you have a great day. Keep trying. I'm proud of you, and I'll see you next video. Bye.